Okay, so we got a question right here. In 1897, J.J. Thomson demonstrated that electrons are small negative particles, right? The diagram shows the apparatus used by the Thomson, right? So a potential difference V was applied across the metal plates, producing an electric field between them, and a magnetic field of flux density B was applied at right angles to the electric field. Okay, electrons were emitted from cathode and accelerated towards the anode. Okay, the electron moved between the metal plates with a speed v. Thomson adjusted B until the electric and magnetic force on the electrons were equal and opposite. So the electrons pass between the metals in a straight line. Okay. So the plates are separated by a distance t. Show that the speed of the electron is given by this stuff, right? So I am gonna use the formula which is that I can see they mentioned about magnetic flux density, right? So and they mentioned about the distance, the speed between them, the potential, right? The potential difference as well. So right, I'm gonna use the formula which is F is equals to BQV, right? So why did I use this formula, right? So because he said that the electric and magnetic force were equal, right? So this is an magnetic field formula, right, which is F is equals to BQV sine theta, but as sine theta is 1, so I just wrote F is equal to BQV, right? So and the next formula I'm gonna use is basically F is equals to E by Q, which is the point charge formula, right? Electric field strength for a point charge, right? So why? Because we have used alpha particles in it, right? So we have to use these two formulas as well, right? And then I use the formula E is equals to V by D, right? Why this formula as well? Because as we can see, there are metal plates, right? Metal plates are basically this formula is basically for parallel plates, right? So we can see metal plates are basically parallel to each other, right? So we can use this formula as well, and we also needed, right, the electric potential we needed to include, because as we can see the formula that has been given to us, the speed, right, is basically containing electric potential, and it also contains magnetic flux density, and it contains a distance d, right? So let's start making them equal, right? So I have BQV, and then I can make it equal with this EQ, right? Okay, so I can just eliminate these two, because there can be eliminated by dividing these two stuff. Okay, so now I have BV and E, right? BV is equals to E, right? So now I know E is basically my BV is equals to V by D, right? So I need the velocity, right? I need the velocity, right? So V is equals to V, which is electric potential, this is velocity, right, and B, and this is T, right? So this is your answer, right? Remember that I use the formula because of the given question info that I have been given. I have been given about magnetic, they are talking about magnetic fields. They in the diagram they show about metal plates with basically equals to using the parallel plates formula, we use magnetic field, and we use the alpha particles, right, as well, which is a point charge, right? So that's why I use these all three formulas, right? So this is our final answer.